Okay, so welcome back to physics. This is lesson 3 on projectile motion. So when you open your notes, I'm really trying to enforce that you don't download your note from the Google website anymore, not from my website, but make sure you open your Google Drive, the folder that you've created, and open the same lesson package that we have done from before, right? One good way to check is, can you see the notes that you have done from before? Okay, so we're now doing review on projectile motion. So we did talk about kinematics and acceleration along one directions. Now projectile motion is two different motions that we'll be talking about. So a very simple way to kind of split it into two is there is the x motion and there is the y motion. So y is like going up and down. I'm just going to draw downward for now. Keep in mind that the x direction, if you study this picture of this guy flying through this dirt bike, if I study these kind of motions along the x direction, I'm just finding the midpoint and drawing it. Notice that it's equal distance the whole time. What that, like, the distance between the sections are exactly the same. What this means is along x, we're dealing with constant velocity. And the implication for that is whenever we're dealing with constant velocity, there's only one equation we're allowed to use, which is the delta d over the delta t. The displacement over time is the average velocity. Okay, so every time when we're dealing with projectile motion that's along the x direction, these are the one that we use. And when there's 3 variables, we're mostly looking for 2 given and 1 unknown, right? Okay, now let's study the y motion. I'm going to change the color into red. Now let's study the guy. I'm going to start drawing line this way, kind of midpoint of the bike. Do you see the distance are not equal in between? What that means is, hopefully you remember that basically while the guy is going forward, the blue motion, the constant along x, it is also experiencing a gravity that is pulling it downwards. It is experiencing an acceleration due to gravity downward at 9.8. And when things are accelerating, the equations that we will be dealing with will be the 5 equation. I call it the high fives, the one that we review from the last 2 lessons. The high fives. I gotta write it correctly. Okay, the high fives, right? So your kinematics equation, the one that involves the acceleration. And in general, with projectile motion, there are kind of 3 main kind. I just call it case 1, case 2, and case 3. And I'm going to review it first before we actually go into the notes and going through it. I would strongly suggest you get a sheet of paper and draw these out. Have more space to draw these out. Okay, so the first kind of motion is I'm going to call it case 1. Okay, case 1 is there's an object and it started off with a horizontal velocity. So like if I have an object that is, say, on a table, and then I have a marble that is going to, from the table, going horizontally with a whatever velocity, and it's going to fall, experience the acceleration due to gravity, and it's going to hit the ground. Okay, the term that we used a lot of time is, we would call this the range. The range is basically how big the displacement along the x direction. So how far away is it going to land from where it started? Okay, and with these types of motions, because we already talked about, it will be split into x and y. So when I do my data list, it's a good idea to break them into x and y and fit in your information that you know. Okay, velocity along x will be whatever the velocity of the marble is, right? Because it's all going horizontal. Okay, at the same time, but how about the velocity along y? Okay, right at the beginning of at the marble, your initial velocity along y, is it going up or is it going down? It's nothing. It is actually 0. I'm going to actually highlight this because this is what most people miss, is they miss that, along the y direction, going up and down, the velocity is 0. Okay, so one thing I didn't do good is don't forget your vector symbol on top. These are vector quantities, so you have to have this little arrow on the top. Okay, and then what I also do know is there are some displacement. This is the displacement along y. Do you see that? Okay, so this is delta dy, whatever it is, that's a displacement along the y direction. And because we talked about along y, there is an acceleration due to gravity, we always know that a is 9.8 meters per second squared down. I'm just going to put the direction down. And then whatever the range is, we call it the dx, whatever the displacement along x. And one very important aspect that you keep in mind is that along x and y is the time. The time is the same, meaning as the marble is going forward along x, it is falling along y. It is actually the same motion. So it depends on what's given and what are you looking for. Sometimes you can soften the time in the y direction and plug it into the x, or vice versa, depending on what's given. Okay, so this is case 1. Case 2, it's what we call the level ground. Okay, and usually it starts off like that. You're on a level playing field and you launch an object with whatever the velocity, and I want to say 99% of the time they give you an angle that is above the horizontal. Okay, like you are a football player, you kick this football and it starts flying off through the air and then it started landing on the ground. Okay, if you want to pause and write out your given list, that would be great. If you want to pause and fill out your chart, what do you know, what do you not know? Okay, x and y. So, what is the velocity along x and what's the velocity along y? This is the part that you have to break them into component, because part of it is going x, like it's going forward but while upward at the same time. So, you actually could have figured out what is x, y. You're going to use the component that we talked about. Okay, this v that is given is always going to be your hypotenuse, right? You have your angle, you want to find your adjacent, right? So what this vx, okay, I'm going to call this the vx, velocity along x, is going to be the hypotenuse times the cosine of theta, right? So hypotenuse is v, cos of theta. Okay, so this is your vx. V is whatever the velocity of the football when you kicked it. Okay, the y is the y component. Okay, the y component that's going upwards like that, right? So this is your vy. I'm just going to match it up here just so that it becomes a triangle. Okay, my pen's running out of battery. So this right angle triangle, if this is the side and I wanted the opposite, this will become the sine. This is v sine of theta. That is your y component. So this is your vy. And this is v sine of theta. And it's v sine theta going up. Okay, I'm not going to worry about the plus or minus sign for now. I'm just going to write the direction behind it. Okay, what else do I know? Okay, along x, I don't really have anything else. I know I could look for dx. Most of the time they ask for the range, so I don't have that. Along y, what else do you know? Oh, acceleration due to gravity, right? Because we know this one is always going to be 9.8 meters per second squared down. I don't know. Do you know? What else do I know? I know I need 3 givens and 1 unknown. I have 2 on the right. I need 1 more. You do know 1 more. I need you to see if you can think of it. The object started on the ground, and it goes up and it comes back down to the ground. There's an extra piece of information that I'm going to write it out for you now. Delta D is 0 along y. It went up and it went back to the same level. Okay, I'm going to highlight this because this is another one. When case 2, this is what people missed. Okay, and then we're going to fill out the rest of it. So I got time. So if I have these 3, I can solve for my time using the kinematics equation. Okay, and if I have the time is the same. So I need you to keep in mind, same thing along x and y, the time is the same. Okay, case 3. Case 3 is usually not a level ground anymore. Say, for example, you're standing on a cliff and somebody hit something with whatever the velocity, with whatever the angle is. I'm going to draw it better. This is not a good picture. I'm just going to start it off like that. Okay. And you are a certain height, whatever the height is, above the ground, and it goes and it landed on whatever this level is. Okay. And then they're asking for range or whatever. Okay. X and Y. Every time when the velocity is on an angle, you're going to have to find your component of your Vx and your component of your Vy, which is exactly the same as what we have done before. So I'm not going to go in detail and explain how to do components anymore. We did that on the last two lessons. Okay, so along Vx, I'm going to have velocity cos of theta. Along Vy, I'm going to have velocity sine of theta, and this is going upwards. What else do I know? Same thing as before. Along Y, I always have acceleration due to gravity. But make sure you put this. I know that is 9.8 meters per second square. And my displacement, I started at this spot and then I go all the way down to the bottom. So my displacement is starting point to ending point. So whatever this delta D is, I'm going to call this delta dy, whatever they give me in the question. You're at a cliff 10 meters above the level at the bottom or something. Okay, so that's my delta dy. And I am going to write this down. So whatever delta dy is, but don't forget this time it's down. I forgot to write this. This is down. And when we actually do the example, I'm going to have you change them all. Remember, when you plug them into an equation, all the direction has to be the same before you can put it in. So one easy way to make that happen is you can change this to a negative v sine theta, and now it becomes down. So meaning whatever answer you got, it will be down. We're keeping down as a positive. That's just how I like to do it. Some other teachers like to do it the other way. Okay, and with case 3 questions, you're not on a level ground anymore. These are the one that usually would involve this thing called the quadratic equation, if you remember, because you will have a t and a t square. You're going to have to use your quadratic equation. If you don't remember what your quadratic equation is, please look it up on a YouTube or whatever and learn how to use it. I have an assumption that I think you know how to do it. Okay, you know how to do quadratic equation. So I'm going to write that out for you. So you're going to, quadratic equation, you're solving for whatever the unknown. In this case is your t. Okay, and you got your ABC. So you have to put your equation into a standard equation. So this is your standard equation, right? You got to rearrange whatever equation you have into ax squared plus bx plus c equals 0. And to solve for whatever x is negative b plus or minus root of b squared minus 4ac, all divided by 2a. We will do examples that involve this, so no stress, okay? All right, now just definitions, very quickly going through this. So a projectile motion is a parabolic and is caused by the acceleration due to gravity. Okay, we always assume the horizontal to be constant, and that's why whenever it's horizontal, we only have one equation to work with. Okay, and so that means the acceleration along x is 0, and the vertical acceleration, it's constant because of the acceleration is constant because of gravity. Okay, the time of the flight is mostly determined by the vertical motions. And here is an example. Okay, the rate that is dropping, it's the same. Okay, but notice that one object went straight down and the other go forward and down at the same time. Okay, so that's just a summary. I'm not like I already did the summary for you. If you want to take a look at it, be my guest, right? So that just, I'm going to actually go through examples together. Question 1. Okay, a child sits straight up in the wagon that is moving to the right at a constant velocity. The child extends her hand and throws the apple straight upwards from her point of view. When the wagon continues to travel forward at a constant speed, if air resistance is neglected, where will the apple land? Will it land behind the wagon, in the wagon, and in front of the wagon. So you can pause the video, write your answer down, decide on what you think. Okay, the answer is it's going to be in the wagon. Okay, the wagon here is moving at a constant velocity while this child is sitting on it with an apple in the hand. Alright, so I'm an artist, you know that. Wagon has wheels. Okay, so what that means is the apple also would have the same velocity as it is, right? The same cart, because the apple is moving in the cart, in the wagon. Okay, the key thing to keep in mind is that it is independent, right? The X motion, the horizontal motion, is independent of the vertical. Okay, so what that means is while the apple is going up and down, these two horizontal motions are exactly the same, meaning as the apple is moving upward, it is also traveling forward at the exact same time as the wagon, so that means it will catch and be landing into the wagon. Number 2, a boy on a small hill aims a water balloon. So I got a boy, he's aiming his water balloon slingshot horizontally straight at a second boy from a tree branch a distance D away. Alright, so we got a tree and some branch here. And you got a boy. Oops, the boy's not hanging by the head. Hold on. The boy is hanging. Okay, that doesn't make sense. Okay, let's do it again. You're probably a better artist than I am. Okay, let's try again. I got a tree. The tree has branch. I got this boy with a head and leg and has arm that is there you go, hanging on the tree. Okay, and then somewhere over here you got another boy. He is launching the slingshot horizontally. So you got another boy with a slingshot aiming horizontally at the boy. At the instant the water balloon is released, the second boy lets go and fall from the tree, hoping to avoid being hit. Show that he made the wrong move. As he's aiming, the bullet will not travel straight horizontally. The bullet will be under the influence of gravity, but at the same time, this boy is under the same influence of gravity, meaning the rates of falling are exactly the same. So basically, it means this picture. So he will get hit, okay, like the bullet will come and fall and will hit him because the rate of falling of the bullet is the same rate of falling of the boy, but the horizontal won't change because he was aiming at it. It will go forward as it's dropping, matching the dropping rate of the boy, so therefore he will be hit. Okay, number 3. A movie stunt driver on a motorcycle speed horizontally off a 50 meters high cliff. How fast must the motorcycle leave the top of the cliff if it was to land on a level ground below 90 meters from the base of the cliff? How much time does the driver spend in the air? So 2-part question. So I got a cliff. I always like to draw pictures with these types of questions. You got a motorcycle, okay, and the height of the cliff is 50. And they're asking you how fast. So they're asking you V. What is V? So that it will land 90 from the base. So they're giving you this as 90 meters, and they're asking you two things. They're asking you for the time and the horizontal velocity. So it's always a good idea to decide if it case 1, 2, or 3. This is a horizontal question, so we did like a little summary chart that this is going to be a case 1 question. So let's fill it out and see what we know and what we don't, and we'll work on that. Okay, so along x, along y, vx is what we're looking for. Okay, I have 90. 90 is along the x, so I'm going to fill in 90.0 meters. You want to say this is going forward. And then my Vy, I know that the delta D along Y is 50.0 meters going down. And we know that every time for projectile, when I'm going downwards along Y, I always know that acceleration due to gravity is 9.8 meters per second squared down. And remember the one I asked you to highlight. Most of the time, people would miss that V1 along Y is actually 0 meters per second because I am not going up and down, but I do need that as my third variable because I need to find one of the 5 equations to help me solve for my T and to help me solve for my V instead. Okay, because right now with along X, the equation that we would use for along X is velocity equals to delta D over delta T. But I only have the delta D right now. I don't have the time. So that means I actually need to answer the part 2 question, find out how long he's going to be in the air, my delta T, before I use that delta T and to be able to solve for the velocity that I will need. So I'm going to start off with the Y. Okay, we review the kinematics equation a little bit. At this time, if you haven't gotten your equation memorized, I would really suggest you work on that. Just because you're going to be using it so much. I always require my kids to memorize it. I know online it's a little bit hard. You'll be like, well, how is she supposed to know if I haven't memorized? I can stick it on the wall. It's up to you. Eventually, I think the pathway for this course is to go to university and being able to problem solve. Certain things you're expected to memorize, and speed is the other thing. If you have your equation memorized, a lot of time you will be able to solve the problem faster because you know it well. If it still takes you a long time to be digging through your 5 equation, you're wasting time, and when you write an exam, you might not have enough time. So that's a challenge that I want to give you. Okay, so back to this. I have 3 given and 1 unknown. I have D, A, V1, and T. I don't have all my 5 equations on hand right now, but if you can go back to your note if you want, look for the 5 equations. Which one of these only had these 4 variables, 3 given and 1 unknown, what they are. So this will be, I call that equation, I'm going to say that this is the delta D equals V1 delta T plus 1/2 A delta T squared. This is the only equation that only involves these 4 variables, but not the V2. Then I'm going to plug in my numbers. I know that this is 50. Okay, the next thing is check your direction, right? They're both down, so we're ready to go. We don't have a direction that are opposite because if we do, we have to change it before we start plugging the numbers into the equation. Okay, so delta D is 50. It equals to V1, which is 0. Anything multiplied by 0 is gone, right? I have 0 times T, but that just means 0, so I'm just going to cross it off. Equals 1/2 A is 9.8 delta T squared. I'm going to change the color of my pen. These are the things that you don't have to write out. If you're good with your calculator, you're rearranging the equation. I don't know how comfortable you are with that. But if I were to solve for this, I could literally just write out delta T equals to an answer. Because when you do a question like that, to get a full mark, you basically need to write the equation, plug in your numbers, and then you get 1 mark for your final answer, right? But I am going to write out the steps of how to do it just to make sure we're all good. But you don't have to show anything that is kind of in green, okay? So what I need to do is I need to get rid of the 2. The 2 is at the bottom. So there are different ways you can do that, right? You can multiply out the half by the 9.8 and make it into 4.9 if you want. But I'm just going to go a step at a time because I want to just use my calculator at one point. Okay, so 1 times 9.8 divided by 2. So to move this over, you would multiply. So you would have 50 times 2 equals to 9.8 delta t squared. 9.8 is on the right hand side. I need to solve for my v2. That means I need to move the 9.8 over to the other side. This is multiplying. That means I need to divide it by 9.8. And this equals to delta t squared. So to find your t, I will need to take the square root of both sides, right? So that I get rid of the square. So to punch it in the calculator, you would go 50 times 2 divided by 9.8, press equal, and then take the square root of it. So 3.19438. So the answer for t, I'm going to now change this back to the blue colors because this is the one that I do need you to write out. Okay, so delta t is equals to 3.194 blah, 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 blah. So how many decimal places do I keep? We look at these things called significant digits. We look at the least number of significant digits that we have, and then we always round our answers to that. So to talk about the significant digits, this number 50.0 has 3 significant digits. The 90.0 has 3 significant digits, but don't forget you use a 9.8. 9.8 has 2. So what that means is you would round your answers to 2 significant digits. So 2SD is what I'm rounding it to. So I look at my answer, instead of 3.194, I would write 3.2 seconds. Okay, so now I've gotten that this is 3.2 seconds. I am now going to use this value into the x direction, and I'm going to use the x equation. So this is seconds. Okay, I'm going to use the x. I'm just going to change color so you can see it a bit. So I'm going to use the red. I'm going to continue this question over here. To solve for the v that I will need, I know that the along x displacement is 90, and then I have to divide it by 3.2. One thing to keep note is that right now inside your calculator, it has memorized the 3.19438 blah, 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 blah. So instead of typing in 3.2, instead of physically typing in 90 divided by 3.2, what I would do is I would type in 90 divided by the answer that was stored in the calculator. Find the ANS button on your calculator, right? So 90 divided by ANS, my answer worked out to be 28.17, so on and so forth. Round it to 2 sig. So the answer is 28 meters per second. Okay, so that's my answer, and that's my answer. So those are the two. So if you were to write your therefore statement, the time it takes at 3.2, and okay, so question 4. A football is kicked 37 degrees with a velocity of 20. Assume the football leaves at a ground level. Leave the foot at the ground level, calculate. I'm actually going to not do A, D, and E. I'm going to focus on just B and C. Those are more the typical type of question, and then we're going to talk about A and D and E. Okay, so B, asking you what is the time of travel, and C, how far away is it going to hit the ground. So the picture looks like that. You are at a level ground, and you kicked it with a velocity of 20 with an angle of 37 degrees. If they don't say it, you are assuming that it's above the ground level. 37 with the x-axis. And it's going to come, fly, and it's hit the ground. So they're asking you time, and they're asking you for delta D for now. Okay, I'm going to ignore A, D, and E. Okay, so do your chart. Decide what case this is. This is a level ground, so this is going to be a case 2 type of question. So you can refer to your paper if you want, right? So along x and along y, because the velocity is on an angle. What that means is I have to find the x and y component of the x and the y velocity. So Vx, what is the x component of 20 with the 37? The x component means the cosine because I am using the adjacent of it. That's the x level. Okay, So 20 cos of 37 along y, this is your v1, the initial velocity along y, v1. And v1, it is the sine and is going upwards. I don't know how comfortable you are with directions. I like to get my student to just kind of get used to formats. So I always assume down to be positive. So meaning if this object is going upwards, I stick a negative in front of it and assume everything down is positive. Okay, so that's just how I like to do that. And so because this is the component, so it is going to be 20 sine of 37. Okay, and then keep going. Hopefully you remember. So we were asking, I think this is all that we have so far, but don't forget, right? I'm still dealing with acceleration due to gravity along the y direction. So A is still 9.8 meters per second down. Because it's down, I'm leaving it as positive. And then I also have displacement is 0 because along y, remember this is the one that people always forget, because along y, I go up and I go back down to the same spot. My displacement along y is 0. So first one asks for what is the time of the flight. So delta t is what I'm looking for. And when I have 3 given and 1 unknown, I find the equation, and d, v1, a, and t, I use the same equation as I have been doing for a long time. So delta d is v1 delta t plus 1/2 a delta t squared. Plug in the stuff I know. Delta d is 0. v1 is negative 20 sine of 37. I don't know what time is. I do know the half times a is 9.8, and I have t squared. Because this is a negative, I can swing it over to the left hand side. Okay, so 20 sine of 37 times time is equals to 4.9. Are we okay? 1/2 times 9.8, I just simplified it, equals to 4.9. You now have a t on one side and a t squared on one side. So what you could do is you can divide both sides. We use the term called canceling. When you have the same thing in every term, you remember the math language, this is a term and that's a term. I got 2 terms and they both have t in it. I can cancel it. Basically what canceling means is I'm dividing both sides by delta t. So t divided by t is gone. It becomes 1 t squared divided by t. It's just leaving you with one of the t's. Okay, so now cleaning this up, 20 sine of 37 is 4.9 times t. Divide both sides by 4.9. My time would work out to be 20 times sine of 37 divided by 4.9. Gives me 2.456. Okay, take a look at your sig digs. I have 3 significant digits with the 20. I have 2 with the 9.8, so I'm going to keep 2 sig dig. Keep in mind, angle, we don't count it in the sig dig. Okay, so only the values. So I have 2 sig digs, so to round 2.456, it becomes 2.5 seconds. So I know that the time it takes along the y is 2.5 seconds, and I remember for projectile motion, the time, it's one motion going forward while going up and down, so this is also 2.5. Okay, and then now I'm going to figure out what is how far, so I'm just figuring out delta dx. Okay, so constant velocity, I only have one equation that I get to use, which is the velocity is displacement over time. Velocity x, so make sure I'm using this, right? Velocity x is 20 cosine of 37. It equals to delta dx divided by the time, which is 2.5. Remember I said don't punch in 2.5, but try to use the ANS button that you have. So to rearrange the equation, I need to solve for delta d. That means I need to bring the 2.5. It used to be dividing. That means I need to multiply the 20 cos 37 by the 2.5, which is the answer. So I'm going to go 20 cos of 37 times ANS on my calculator. If you want to punch it in, you can punch it 2.5. Okay, just rounding wise, I think it's a good practice to leave your rounding to the end. So what I got is delta D, all worked out to be 39 meters. Displacement is a vector. If it doesn't say, you have to say that it is going forward. So okay, now addressing A, what is the maximum height? Your data list would change a little bit because at the maximum height, I'm actually talking about this point right here. That is the part where the part A is, where's the maximum height. Okay, maximum height happens. My V1 along Y is the same. It is still going to be a negative 20 sine of 37 because it's going up. But be careful, at the maximum height, your V2 is 0. Right? So V1 going up, V2 is 0 because that's the maximum height. I still have my acceleration equals to 9.8 because gravity is still pulling the same way, which is going down. And when they want the maximum height for part A, I'm not going to finish all the question, but I'm going to say that basically you're looking for what is the displacement along the Y. That's your maximum height. For part B, they are now asking you what is the velocity at the maximum height. You'll be like, hey, didn't you say the velocity is 0? But don't forget, at that same time, you still have a horizontal velocity that is still traveling at 20 cos of 37. The whole time, I'm going to scribble a little bit over this picture. I'll erase it afterwards. The whole time, the velocity at any point, you will still have the x. But at the same time, you actually will have a y direction. I'm going to change the color. You have a pretty big y, eventually getting smaller and smaller to the stop. And then you will start coming down with the velocity that's coming down. So the actual velocity is the sum of the two. So what that means is for part D, to figure out what is the actual velocity at the maximum height, it is basically going to be only the x, because right at that point I don't have a velocity that's coming down, right? So I only have the x direction. So this is the only one that I have, which is mean that the overall velocity would equals to vx equals to 20 cosine of 37. Part E, light E, the velocity when it strikes the ground. So we're now looking at when it strikes the ground. We know the green, okay? We know that going horizontally, I will have Vx, which is 20 cos of 37. What's going downwards, different ways that you can think of it, it's almost like I'm now changing my data list. My V2, it's actually traveling downward this way. At what speed? It is coming down at 20 sine of 37. Because this is a level ground. This is more a concept than a math question. This is a level ground. The rate that is going up, it's the same rate that is coming down. So meaning as it is going up, the speed is decreasing, but then when it's coming down, it's increasing the exact same way. So without even doing any calculations, your answer, it's 20.0 meters per second, 37 degrees forward and down. Do you see that? It's the exact same thing as the value you started at the beginning, but just at a different directions. Okay, so it doesn't involve any calculations. It's more, do you understand the concept, the rate of going up? Okay, question 5. A golfer on a tee strike a golf ball, giving it the initial velocity of 42 meters per second, 32 above the horizontal. If the ball lands on the green is 15 meters higher than the tee. How far away is the green? So you got initial velocity of 42, which is on an angle, and it is on an angle of 32 above the horizontal. And this time, it is going to go and land actually on a higher ground. Usually we do a lower ground. We always go cliff and stuff like that. But this time it's a higher ground. So this is 15 meters higher than the level that it was starting in. Okay, so take a look at the picture. This is the case 3 type of question. If you could, don't look at the chart we made, but if you need to look at it, that's okay. All right, so try your best to write it out without looking first, okay? So you still do your x and y. Velocity is on an angle. We split it into component. You should be getting a vibe that is very repetitive at this point. So along x, it's 42 cosine of 32 degree. Some of you might feel more comfortable to be punching in the answer, which is fine. I'm just going to leave it as is right now. This is v1 along y. Like initially, what is the velocity that's going upwards? It is going upwards at 42 sine. I keep saying cosine. 42 sine of 32 degrees. This is going up, so I'm going to put a negative in front of it. That's just me liking it like this, okay? I always assume down to be positive. So anything that's going up, I stick a negative in front of it, right? Okay, keep going. Along y, it's always experiencing the acceleration due to gravity, pulling it downwards. And I know the displacement along the y, I am now 15 meters higher. So it's negative 15 meters. So it's negative 15 meters down. I just keep in mind, everything that is going down, I keep it positive. So anything that's going up, I stick a negative. That's just what I'm so used to. I do it all the time. If you swap everything, it's okay. If you want up to be positive, you just flip everything, but then don't forget to flip your 9.8 to a negative then. Okay, so then the next thing that I need to know is what am I looking for? I'm looking for how far away is the green. So I am trying to find what is the delta D along with, okay? So in order for me to find that, I will need to first of all calculate what is the time, and I will need that time from the y direction. Okay, just like same thing. I have V1, A, D, and T. I find the equation that I need, and it's the same equation. Okay, so I'm still using equation delta D equals V1 delta T plus 1/2 A delta T squared. Plug in my information. Delta D is negative 15 equals to negative 42 sine of 32. And I have my time is my unknown. Plus 1/2 times A T squared. Plug in things that I know. Expand it out. And do you see I have a number? I have a T and a T square. I already mentioned before, every time when you go to case 3, you need to get involved with the quadratic equation. So I'm going to expand things out, clean it up, and put it in a standard form, meaning you move everything to one side and make it into 0. Okay, so this is I'm going to work on the T2. I'm going to work on this term first, right? Because this is my T square. It looks like I'm moving everything to the right-hand side to make it all equals to 0. Okay, so I'm going to go 0. I'm going to take a look at the green part first, okay? Half times 9.8 times delta T squared. I have 4.9 delta T squared. Okay, and then the next term that I'm going to look at are the one that is involving the B, the second one. So I'm going to dealing with this one. Okay, I'm keeping it on the right hand side, so I'm keeping the negative, right? So this is minus. I'm going to punch it in my calculator. 42 times sine of 32 work out to be 22.26. I'm just going to round it a little bit. 22.26 delta T. Okay, and then finally, I need to move my negative 15 to the right-hand side, so it becomes a plus 15. I'm putting it in the standard form of ax squared plus bx plus c. So that means for the quadratic equation, I know that 4.9 is what I'm using for a. Negative 22.26 is what I'm using for B, and 15 is what I'm using for C. Write out your quadratic equation. Negative B plus or minus the square root of B squared minus 4AC, all divided by 2A. Negative B. B is negative 22.26. So the negative of it, I'm going to leave it as a positive. Okay? Plus or minus the square root of B squared. So 22.26. I know I drop all the negatives just because I know when I take the square of something, it's gone. If you need to write it in, it's fine. Just be careful when you multiply it, right? So 4 times A is 4.9, times C, which is a positive 15. I'm going to close off the discriminant. All divided by 2A, meaning 2 times 4.9. I'm going to work out what is inside my discriminant first, the one that is underneath the square root. So 22.26 square minus 4 times 4.9 times 15, taking the square root of that. So right now I have 22.26 plus or minus 14.19, all divided by 2 times 4.9, which is 9.8. I'm just going to clean it out. So with the plus and minus, meaning I'm going to end up with two answers. Okay, so I'm going to work out what the two answers are. So I'm going to add first. So 22.26 adding 14.19. I got 36.44. 36.44. This is my time, so I'm just going to keep a little bit more decimal. 0.4466. Okay, and then I now have the other one. 22.26 minus 14.19 divided by 9.8 is 0.82 seconds. This is time, right? I'm just going to double check the other one didn't look right. So adding 14.19 divided by 9.8. Sorry, I forgot to divide the top one by 9.8. Take it back. 22.26 adding 14.19 divided by 9.8. Okay, so finishing this up, sorry, I messed up my calculation before. This would work out to be 3.72. Okay, so I got 2 times, and then they're asking you how far away is the green. Okay, so question. I got 2 times. Why do I have 2 times? Or what does the 2 times mean? Think about it. Do you understand when you did that in math? Like, right, you found the quote-unquote roots in math. That's what we found, right? We find the roots, the zeros of whatever the answer is. What does it mean? Why do you have 2? Okay. What it means is I am basically looking for the time when it's 15 meters above the ground. Now look at the picture. Now if I ask you, what does the 2 times mean? When you relate it to the picture, can you understand what they're saying now? They're basically saying when the golf ball is at 15 meters above the ground. So the 0.82 would refer to this spot right here, and the 3.72 is to that spot. To be honest with you, we never told you, did it go move here and then hit the 15, or did it go up and down? There is no say as in which point I'm using. So you're basically okay to use either point, because it could be that, oh, the golf ball just got hit. But I think in a regular golf ball situation, I think we are referring to this time more. So in this case, I'm just going to use the 3.72 as the time that we're using here, so that we can figure out how far away, which is your delta dx going sideways. Okay, so finishing this off, along x, the equation I'm using is displacement over time. That's what constant velocity is. There's no acceleration along here. So the x is 42 cosine of 32. It equals to delta d divided by 3.72. Rearrange the equation. Delta d would be 42 cos of 32 times 3.72. So the answer, it's 132.5 meters looking at sig digs. So I'm just going to write the whole thing in. I just feel like some of you might still not remember how to do sig digs, so I'm just going to change it to another color. Let's use green. Okay, so calculator answer 132.477. Might be slightly off because I rounded. I wasn't careful. Okay, now check sig digs. I have 42, which has 2 significant digits. So 2 digits. 15 has 2, so I'm going to keep 2. So 132 point something, I need to keep these 2 and round it over here. So the answer that I'm going to write is going to be 130. Everything else is going to be rounded. Don't forget your units. And I'm also going to put the directions, which is forward in this case. Last but not least, it is solving. You know how like I have two sides to the equation, the x and the y, when it's on an angle. So they're basically saying that this is summarizing for the same height. So this basically is using case 2. And to have an extra equation if you wanted to use it. So they just rearrange the equation, read through it, and the final equation worked out to be this. Remember, this is case 2 only. And if you actually work it out, the biggest value that you can have the longest range, the maximum range, I didn't mean to cross it out. The maximum range happens when the angle is at 45 degrees. That's when you're getting the furthest